guys, and welcome back to lesson 9. We are now in the last basic differentiation rules. We have now chain rule. So let's start. So what is chain rule? So chain rule is actually related to composite functions. Okay, so the idea here is we use the idea of composite function to get the derivative of complicated differentiable functions. So for example, we have, if we let f of x and g of x be differentiable, if we have y equals f of u, and u is actually our g of x, so take note this, if you try to translate this is just f of g of x. Okay, then we have the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So if you try to look at this, we can actually observe that it is somehow treating the derivative as a fraction. But again, this is not, take note that this is a symbol, not really a fraction symbol, but rather a symbol of the derivative. Okay, so let's try to have an example. By the way, for the proof, just refer to the link posted below. Okay, so I will not delve with the proof for this one because it will take time, but just know that it is somehow related to, again, we can use the limit definition, but if you try to look at this, it's like we're canceling du, but again, this is just a primitive, not really primitive, but a layman's observation. Okay, so again, proof in the description below. So let's have an example. So for example, we have this function here. We have y equals the quantity of 2x squared plus 1 to the power of 3. So and we are asked to find the derivative. So if you try to look at this, we don't have any rules. Okay, before the chain rule, we don't have any shortcut to solve for the derivative of this. Okay, so first we let u be the function. Take note, it's if you try to review, this is the inner function. Okay, so we let u be the inner function. So this will give us, so if we try to substitute u to our given function, this will now give us y equals u cubed. Okay, so we just change this one into u. Okay, that's why we have now u cubed. Okay, then we get the derivative of u equals to x squared plus 1. Okay, getting the derivative, both sides, and this will give us 4x, of course, because this is 2 times 2, 4, then x, we subtract 1 to the numerator, and then we have plus 0, which will just give us 4x. Okay, then we also get the derivative of the function. Okay, y. So take note, we get the derivative of u, then we get the derivative of y, and then we'll have 3u squared. Okay, we have now 3u squared. Take note that this is the derivative with respect to u, because our variable here now in the function, instead of x, we have now u. That's why this is du here. Okay, it's du. Okay, so what's the next step? The next step is to substitute the value of u. So what is our u? Our u is 2x squared plus 1. Okay, our u is 2x squared plus 1. Okay, but take note, this is with respect to u. So what do we do now? Okay, so take note that du dx is 4x, which is this, and then we have dy du, which is 3 times 2x squared plus 1 raised to the power of 2. Okay, and then we use now the chain rule. Okay, so our chain rule, to find dy dx, again, our goal is the derivative of y with respect to x, because that is our given. y with respect to x, we just simply multiply the result of dy du and the result of du dx. Okay, so we have this, we substitute, and then we have 12x times 2x squared plus 1 quantity squared. And that is how we solve for the chain rule. Okay, so in the next video, we'll be having more examples. Okay, so see you in the next video. Bye-bye.